The broadcast is now starting. All attendees are in listen-only mode.
Hello, good afternoon or good morning, everyone. Welcome to this presentation on the Blueback System Center. Before we get underway here, I'll just take a minute to explain how this GoToMeeting thing is working in case there's any questions. So we're using this GoToMeeting hosted session. You should have a panel like this, which you can minimize using this orange button if it's getting in the way, like so. And you can also view full screen or windowed using the menu there. By default, everyone's muted, but there's a text dialog to enter questions, and I'll take some time at the end to go through them. So please just pop in any questions that you have into the box at any time. Like I said, there'll be a Q&A at the end of the session, and we'll upload a recording of this to our website within 24 hours. So with that, I'd like to start by saying welcome to this webinar on Petrel performance monitoring with the Blueback System Center. Just a brief agenda of what I plan to show today. I'd like to give you a brief introduction to the Blueback System Center, just in case there's any who haven't seen it before, but that will be quite short. And then I'm going to spend the rest of the time firstly showing you the different tools you have available for performance benchmarking. So these includes some standard tests that are part of System Center, mechanisms to use custom workflows and incorporate them into your performance testing, how to run performance tests using the command line, which might help you when you go to do this and scale it out across your environment. And then I'll also show you how we can do what's called session profiling, and that's capturing more detailed information, maybe about users' Petrel sessions as they're working, and this can maybe more applicable for getting some performance measures on things like that are kind of graphics driven, like NVIDIA GPU usage and things like that. I'll come back to that a little bit later. And finally, once I've shown you how we can acquire all these types of information, I want to talk you through how we work with the results and what sort of conclusions we can draw from that. So just a very short introduction to the Blueback System Center. It's designed to be a tool for IT and data managers to monitor the Petrel environment and to improve support to the users. The System Center collects a lot of different information, and mostly this can be used to get an overview of license checkouts, Petrel installations, and the Petrel sessions, which are startup saves of Petrel, so we can capture some statistics related to that. It also captures some information about Petrel crashes or exceptions, which again we can use to help support the users. It collects some information on all the machines and the particular hardware configuration of the machines, which again we're going to use quite a lot today when it comes to making some conclusions about how different machines perform. And finally, it has some tools for Petrel performance monitoring, which I'm going to focus on today. The amount of detail that you collect with the System Center can be controlled centrally through the System Center itself. And it's also important to note that we can collect this information through the use of command line or scheduled tasks as well. So now I want to dip in a bit more into the performance monitoring side of things and go through some of the details there. So first I'd just like to mention why we do the performance monitoring. Well, really we're after identifying machines or hardware configurations that may be performing poorly, or we want to investigate issues reported by users which may be of poor performance or instability with their daily work. And then I'd just like to set a little bit of a ambition level with the System Center and say, what do we achieve with the System Center? Well, we collect a lot of different measurements, and really we want to do this to build up a picture about how the machines or hardware configurations perform relative to one another. So we can capture a lot of absolute measurements, but really we're just after comparing machines across our environment and seeing which ones are not performing as well as the others. As an accompaniment to this kind of work, we recommend the following textbook, which is called Windows Performance Analysis Field Guide, which has a lot of detailed information about the different performance metrics that we collect and we use a lot in the System Center. So if you plan to do an evaluation of the System Center, we can issue a copy of this book, or it's about $30 on Amazon as well. So just a little bit of background on how the performance monitoring works. The System Center plugin, which you install beside Petrel, contains a bunch of tools for driving the performance monitoring. So this includes creating standard test data, which means that we can run tests with the exact same data to ensure that we get repeatable measurements that we can compare like for like. Using the plugin, we can also execute standard tests, like loading into shared memory or realizing a seismic cube. With the plugin installed, we can also make use of running workflows in Petrel and capture some information about how they perform. And we can also run the tests via the command line, and I'll touch on that a little bit later. It's also important to note that we collect some summary information about the different performance tasks, like start and end time and resources used. But we can also collect a lot more detailed information if we need to dig into specific tasks a little bit more. So in my demonstration today, I want to put performance monitoring in a little bit of context by showing you these 4 different kind of workflows for the tool. So the first is really, how do we measure performance across the environment, and how do we look into how different machines and hardware configurations are affecting different user experience. I then want to show you how we can look at the performance from a custom workflow, which is intended to kind of simulate a typical end user task or end user work. I then want to dig into some of the more detailed performance measures that we make, and stress that these are really used for monitoring slow tasks or severe performance problems that you draw out over time. And then I want to look into something which we call session performance monitoring, where we can enable performance monitoring of people as they work in Petrel, and we can kind of capture any problems they may encounter over time. So I'm going to run through how we set up and run those different tests now and how to view the results. Before we start, I just want to give a very, very brief introduction to the System Center itself, in case there's anyone that hasn't seen it before. So here we have the System Center viewer, which is configured to connect to a central database here in our network. And we have a kind of a dashboard which contains some summary information about the Petrel environment, like active users right now and some idle users, then some kind of key performance indicators like number of sessions per week, the number of users per week, and the startup time of different Petrel versions. As I mentioned, we can configure the information we collect centrally. So what I wanted to show was that from the System Center viewer, we can control how much information we're collecting about specific aspects of the system from here, so we don't need to worry about configuring that separately on every single machine. In addition to performance monitoring, we also have things like overview of license use. So we can, for example, extract license history for particular modules in Petrel or get a monthly report. That's something that's been in the System Center for a while. We also collect information on both the users, so search as Active Directory to find the username and email of a particular user, and we also capture the machines, which are all the machines using Petrel and with the System Center installed. And you can see that we collect very detailed information about the machine itself, including all the NVIDIA driver settings, etc., etc. In here, we also have this ability to turn on session profiling for a particular machine, which will capture more detail about that particular machine, but I'll come back to that a little bit later. Just to finish off here, we also collect the exceptions, so you could see for a particular user if they were generating a lot of exceptions or crashes with Petrel and try and dig into the reason for that a little bit more. And in addition, there's many more things you can gain here from the System Center. But for the purpose of today, I want to focus on the performance monitoring. So the next thing I want to show is how we execute some of those performance measurement tasks inside of Petrel and then work with the result. So I'll come here to Petrel, and when you've got the System Center installed and the license checked out, you get some additional options here on your System Center or your Petrel home screen here. And I can click on firstly this System Center configuration, and we can see that mine's already configured to write all my results back to a central database, which make it easy to share those results across the environment. So I have everything I need to start some of this work here. The first thing I want to show is we have firstly the option to create some test data, which lets you create some standard ZGY cubes of the same size, so that when we start to run performance measures on different machines, we're using exactly the same data and that we can, compare the results like for like. So step one is to create yourself some test data which you can use as part of your performance measurements. Next, we have the profiler tool itself, which is the main interface for executing some of the standard tests using the standard data. So here in this drop-down, I see I have some various options for loading from disk and then into cache of the different seismic cubes, and then a typical realized operation, which is again a fairly standard function of Petrel, but a useful indicator of how a machine performs. So here I want to just test the load 1 gig seismic, and I'm just going to grab my cube from the network here. Grab my 1 gigabyte cube. So you can create this test data on the network, and then you could pick it up from any type of machine. The next thing I have is the option to include profiler sampling, which is like a snapshot every 15 seconds or so. In this example, it's going to run really quick, so capturing every 15 seconds won't add a lot of value. But for longer tasks, we might want to monitor, say, for example, the network or the RAM every 15 seconds to see how it changes. So I'm just going to go ahead and execute that workflow, and it will begin to load that 1 gig seismic cube. You can see it in the input tree there, and then fetch it into memory. So it's just a very simple performance task that we can repeat across the machines to show the differences in performance. So that was just an example of a very basic tool we can use to measure performance. Now I want to show you how we can maybe incorporate a bit more geoscience into some of these performance tests. So I can do that by creating a new workflow in Petrel. And with the System Center installed under the Processes menu, you will get some additional options for Blueback System Center, and then the Start and End Profiler. So this tells the workflow to start recording performance measurements and then end it. And then what we can do is basically add in any standard Petrel process that's available here that we want to run. So we might want to create a volume attribute. And it's also important to note, we had a lot of questions on this morning, that if you want to test maybe a third-party plugin for performance, that can be done if their operations are enabled in this workflow editor. So here, for example, I can test some of our own functionalities like the cut seismic cube and include that information in my performance measures. So here's just another example of one I made, which is a standard test, which I think is representative of what an end user might do with Petrel. It's just starting the profiler and recording the measurements, creating a volume attribute like variance, and then extracting that onto a surface, and then creating something like a structural smooth and extracting an RMS amplitude. So it's just a couple of simple steps chained together to test the different operations inside of Petrel. Next, I want to show you how we can execute those two types of tests via the command line, which might be a better way to acquire this information across the whole environment. So here's just a text copy of my batch script for doing that. So what you can see is we can basically start Petrel in the command line using a particular license package and execute the System Center plugin and tell it to realize the 2 gig seismic cube and give it a cube and some other parameters. Now all this information is contained in the help manual for System Center, so we don't need to worry about the syntax here, but just know that it's possible. And similarly, we can repeat the same command line task for the custom workflow. So again, we basically call Petrel in the command line and run the workflow make surface attribute using a particular project which we could store on the network. So that was just a brief look into how we can collect those same measurements via command line script. The final way we can collect performance measures from Petrel is to use something we call session profiling, which we find under the Machines tab of the System Center. And what we do here is we basically can turn it on for a specific user, and it'll track the performance measurements every, well, in this case, 30 seconds, and it'll just take a snapshot as time goes by. So you could, if, for example, a particular user was complaining of slow performance and maybe was requesting additional memory, we could turn this on for a couple of hours and just to see how much of the machine's resources they were really utilizing and make the case for helping them out. So with all that in place and all those statistics acquired, I now want to work you through some of the case studies I mentioned and look at the results from different performance tests I've run. So I'll do that through 2 main tabs inside of the System Center. The first is the profiler, which contains kind of summary information for all the tasks I've executed. So I can see here all my different tasks I've run across the different machines. And if I just flick through them, you can see I've run some on different machines a number of different times and some more than others. But first of all, I'd like to focus in on this load 1 gig cube, which I showed in my example here. So the first thing I can do is to just show the different results across the different machines here. So you can see that I've run this many times across a couple different machines. And I'm going to change this access to just give me the duration of the task. So how long in seconds did it take to execute? So we can see here that I've repeated this result on many machines, and we get quite a lot of delta here for duration across the Blueback environment. I can also here switch it from showing me the dimension to just average these out. So for each machine I can just create an average, and we can see how that compares over time. So again, what I see here is there's a big delta across the different Blueback machines for executing this load 1 gig. But right now I don't really know why that might be, other than they're slightly different machines. But using the System Center, we can in fact investigate something like the network interface here, and we quickly get a clear picture that the tasks that seem to be taking a long amount of time all seem to be related to a particular type of network configuration here. Now what we should avoid is to say that the cause is not necessarily the network configuration itself, but just the machines that have that in common. So I can see that this element is a common factor of slow performance with Petrel here. Instead of network interface, we can also look at Petrel version, and what I can see is that the performance across the different Petrel versions here is fairly uniform. There's not much delta across the different Petrel versions. Next, instead of using a standard workflow as an example, I want to show you the surface attribute, which is supposed to represent kind of a typical user workflow, so it might give some more meaningful information. And again, I want to switch this to maybe the machine here. So we can see again, I've run this task on many machines a number of different times, and I can average these out across the machines to again make a comparison. So we can see here that there's a couple machines that are executing this task quite quickly, and there's another couple which are quite slow compared to the other machines. Another thing we can do here, which is quite useful, is to display another performance measure next to the graph. And in this case, I'm going to choose to work with the memory available, which is a measurement of the total memory available on that machine. And when I do that, what you can draw from the conclusion is that typically the machines with low memory available take much longer time to execute the task. And that's true for all the results here on this graph. And interesting, what I can see as well is that these two machines here actually seem to do quite a lot with the memory that they have available. So they are a newer breed of machine which is able to really make use of what they have in a very efficient manner. I can also compare some other metrics that we've taken during the task. Instead of memory available, I could also look into working set, which is a measure of how much memory was actually used. So again, we can see some machines able to utilize a lot more memory to execute this task in a much faster way. Instead of working set, we could also take a look at the network interface traffic. So here I could say look at the sent traffic on the network interface, and then we get a measure of traffic in megabytes a second. And again, I can see that some of them were performing much better than others. And interestingly here, I see that one has no network traffic, and that leads me to the conclusion that this person's actually run it locally on their machine and hasn't done it across the network. The next thing I want to show is how we can dig into these workflows in a little bit more detail. And there we use the second tab here called the profiler samples, which is taking a sample every 15 or 30 seconds of all the performance measurements on Windows. So again, here I want to filter by one specific task. So I'm going to look at this realize 2 gig. And what we can see is when I ran that task across a number of different machines here, it took a long time to execute for one user, and then it was really fast for another 3 users there. So it's basically a graph of duration against a performance measurement. So we can see how a particular measure changed during the execution of this particular workflow. So here I'm looking at committed bytes, but again, I could change this to something else. Just to explain, committed bytes is the demand for memory by a particular process. And then if I take a look at maybe the network interface sent, here we can see that some of the users were able to really ramp up really fast and finish the task quite quickly. Others were kind of reasonably slow and steady, and some others were really not able to utilize much network traffic at all, and hence took a very long time to finish the exact same task and the exact same amount of data as everyone else here. In addition, I talked about being able to monitor people's day-to-day work in Petrel, and that's something we can enable in the Machines tab. And I can just show you how we can quality control some of those results. So if I turn off this job here and instead filter for session, I can see that I've monitored my own Petrel sessions for a couple of days now, and I can check my performance measurements across those sessions and really see how my machine's been performing over a number of days. So the first thing I want to look at is maybe again the working set, which is demand for memory. And I can see that I've had a couple of sessions this week which are fairly demanding on memory. I'm reaching some limits here of 7 or 8 gig, but I know that I have around 16 gig in my machine, so I'm confident I have a kind of adequate resource for this kind of work that I'm doing. And what we can also see is I've had a couple of sessions where I've kind of not been inactive at all. It's probably because I've had Petrel open but been doing something else. We can also look, for example, at the CPU usage for a user, and again I can see how my CPU usage has been going on during a particular week. For users doing a lot of seismic data type work, it's also possible to monitor the NVIDIA, usage and memory, and see how that performs over a particular period. So something like NVIDIA usage is quite difficult to capture using a standard task because anything with graphics is kind of, driven by user input and driven by volume rendering. So here it might be more applicable to use the session profiling to capture information about how the NVIDIA use is behaving. Before I open up for questions, I would just like to recap with a couple of slides here. So I showed today that we can execute some standard tests using the Blueback System Center and run these across different machines and build up a picture of the deltas in performance across my environment. And I can eventually average those out to see how things are changing over a longer period of time. So I could periodically run these tests over time and then average them out to make sure I'm getting the whole picture. I've also shown that we can, for example, look at machines and how they perform, but we can also group by, for example, Petrel version or network interface to see how different elements are influencing the performance. I've also shown we can compare running of custom workflows, in my case a kind of volume attribute and surface attribute workflow of a couple steps tied together, and we can look at the amount of time taken to execute that workflow on each machine compared with some of the other measurements like memory available or CPU usage, etc. We can also dig into more detail with some of the workflows if we want, and we can look at how the different measurements performed over the duration of the task and how different users were influenced by limits in their hardware. In addition, for some workflows, it might be more applicable to just take snapshots of the performance. For example, as I mentioned, some of the more graphical intensive workflows where you want to look at GPU use. So we can do that using the session profiler and look how a typical task performed over its duration. Before opening up for questions, I'd just like to say a couple of words on best practice for executing these tests. Ideally, you could build a standard script that you store on the network and people could just then pick up and run on their local machine, and you could feed in the same project and the same workflow into that task and they could run the same thing locally on their machine. If you're in the position where you've actually deployed System Center, then you have information on the machines and the users. So then, in fact, you can build an even smarter scheduled task to do all of that for you, since you'll be able to know the machine names and the location of the Petrel installations for each of the machines. I'd now like to open up for questions and answers. So if you have any questions you'd like to ask, just drop them into the box now, and I'll take a minute to review some of the questions that we have. Let's see here if I can find my questions. Yep. So no questions coming in except some questions about the audio. Any more questions you have just now, just drop them in. Can you import test data rather than create them? The answer to that is yes, you can use your own data in the test. You just have to be a little bit wary of doing that. The idea with the standard test is that you're definitely comparing like for like on the different machines as you run them. Then it's what components need to be installed on the user's workstations. In order to capture information about the performance on the machines, you need to have installed the System Center plugin. If you want to run the profiling tasks, you must toggle on the System Center license as you start Petrel. But in normal circumstance, if you're just capturing information about the users, then that information is collected whether they toggle on or not. What type of data types can be created? The System Center just uses some standard seismic cubes, and it can create or use anything that's available inside of Petrel. And how much overhead does the collecting of data impose on the machines is another question we have here. There is a very small overhead on collecting these results, but we've hard-coded a very low timeout of connecting to the Blueback System Center database. So if it takes longer than a quarter of a second or something, it doesn't bother. But also I showed we can control the level of information we collect centrally. So if you want to dial it down, the amount of information you collect, you can do that. Will the System Center allow us to monitor the cumulative use of individual Petrel modules on stack on start over time? Yes, we can monitor stack on start quite well, because you choose different options every time you start Petrel. The area where the license monitoring can be a bit of a gray area is if you have these fixed bundles and you're forced to check out features all the time that are tied to specific bundles. Then we have a question on Studio. I had a Studio as the name of the database. No, that's just a name we have for a test machine here. There was a couple of more questions that came in at the end there, but I think we're soon out of time on the webinar, so we can respond to those just by email. And if you have any more questions, then please let us know on sales@bluebackreservoir.com. And if you want to also run an evaluation, then we can definitely help you do that. So with that, I'd just like to say thanks very much for attending.